Question 857. The figure above shows the graphs of the polar curves r is equal to 6 cosine 2 theta and r is equal to 6. Use the appropriate calculator to solve each of the following. Write an integral expression, but do not solve for the area of a shaded region. Okay, we have two polar curves, and one of them is r is equal to 6, which is the circle with the radius 6. And the other one is r is equal to 6 cosine 2 theta. That curve is right here, right? R is equal to 6 cosine 2 theta, right? And what I'm going to do to find the area of the shaded region is that I'm going to find the area of this circle, right? And then subtract the area of this polar curve right here, this area, all right? That's my strategy to find the area. First, what is the area of the circle? That's area of the circle is just the pi r squared. The radius is 6. So that's a 36 pi, right? And we're going to have to find the area of this polar curve right here, right? Always start with the theta is equal to 0. So substitute 0 for theta. Then cosine 0 is 1, right? So r is equal to 6 times 1. That's a 6. So we know that the graph starts right at this point, right? When theta is equal to 0, r is equal to 6. Here's a 6. Okay? And then next step is substitute angle theta that is close to angle 0. So I'm going to substitute, in this case, pi over, let's say, 6, 30 degrees. Then cosine 2 times pi over 6, that's cosine pi over 3. Cosine pi over 3 is 1/2, right? So r is equal to 6 times 1/2, that's 3, right? So when angle is at 30 degrees, it's about this, right? R is 3, so r is 3. The coordinate is right here, right? So this coordinate right here is in polar coordinate. That's 3 comma pi over 6, right? Okay, now find the coordinate where r is equal to 0. So this coordinate right here. Okay, r is equal to 0 when theta is equal to, well, cosine pi over 2 is equal to 0, right? Since cosine, we have 2 theta, this angle must be equal to pi over 2. So 2 theta is equal to pi over 2. Then theta is equal to pi over 4, right? So we have the coordinate at this point right here at the origin or pole, right? When theta is equal to pi over 4, right? So this coordinate is equal to 0 comma the angle pi over 4. So the area of this region right here, from here to here, this region is going to be integral from 0 to angle pi over 4. The area of the polar curve is formula, right? 1/2 r squared d theta, and that r is equal to 6 cosine 2 theta, right? 6 cosine 2 theta. This definite integral represents the area of this part only, right? So we're going to have to subtract 8 times of this area from the area of the circle, right? So area of the shaded region is area of the circle minus 8 times integral from 0 to pi over 4, 1/2 r squared, 6 cosine 2 theta square d theta, right? So if we simplify this, that's going to be 36 pi minus, here we have 4, right? But we have a 6 squared. 6 squared is 36, right? So 4 times 36 is equal to 144. So 144 definite integral from pi 0 to pi over 4 cosine square to theta d theta, right? That's an integral expression for the area of the shaded region, right? Question A58. For thetas from 0 to pi over 2, write the equation of the tangent line to the curve r is equal to 6 cosine 2 theta at the origin. Okay, at the origin, right here at this point, right? R is equal to 0, and we know that r is equal to 0 when theta is equal to pi over 4, right? Because cosine pi over 2 is equal to 0. So the question is to find the equation of tangent line at theta is equal to pi over 4, right? Okay, let's find the slope of the tangent line. Slope is equal to dy over dx, right? But in polar curve, we have to write dy over d theta over dx over d theta, right? And we know that y is equal to r sine, x is equal to r cosine, right? R is given as 6 cosine 2 theta. So 6 cosine 2 theta times sine theta, that's our y. So our derivative of y respect to theta is equal to, here we have constant 6, so leave this one alone. Derivative of cosine 2 theta, that's negative sine 2 theta times chain rule, derivative of 2 theta, 2, right? And we have sine theta plus, we have cosine 2 theta, then multiply by derivative of sine theta, cosine theta. So far so good. Now, we're going to find the value of dy d theta when theta is pi over 4, right? So when theta is pi over 4, that's going to be equal to 6 times sine pi over 2, that's 1, right? So negative 1 times 2, sine pi over 4, that's root 2 over 2, plus cosine pi over 2, that's 0, right? So 0 times root over 2, that's a 0. Okay, so that's going to be equal to, we're going to cancel these two. So 6 times the negative 1 times root 2, that's negative 6 root 2, right? Okay, now let's write the x. X is r cosine, right? So that is equal to, r is 6 cosine 2 theta times cosine theta, right? So dx over d theta is equal to 6 times derivative of cosine 2 theta, that's again negative sine 2 theta times 2, and we have cosine plus cosine 2 theta times the derivative of cosine, that's negative sine, right? Now substitute pi over 4 for theta. Okay, so that is equal to 6 times, here sine pi over 2, that's negative 1, 2 cosine pi over 4, that's root 2 over 2, plus here cosine pi over 2, right? 2 times pi over 4, that's 0. So 0 times whatever value, that's actually negative root 2 over 2, that's a 0, right? So that's going to be equal to cancels out. This is also 6 times negative 1 times the square root of 2, so negative 6 root 2, right? So our slope when theta is equal to pi over 4, which is at the origin, is equal to negative 6 root 2 over negative 6 root 2 is equal to 1, right? So our equation of tangent line, which is equal to y minus y1 is equal to slope m, x minus x1, that's our equation of the line, right? Slope is 1, This slope is 1. And we are looking for the equation of the tangent line at the origin, right? At the origin, the x coordinate and y coordinate, they are 0, right? 0, 0. So 0, 0. So our equation y is equal to just x. That's our equation of the tangent line at the origin. All right? Question A59. For theta is from 0 to pi over 4, there is one point P on the polar curve r is equal to 6 cosine 2 theta with the x coordinate 2. Find the angle theta that corresponds to point P. Also, find the y coordinate of point P. Okay, here is our polar curve. R is equal to 6 cosine 2 theta. And when x coordinate is equal to, it's about right here, right? Our point P is right here, right? Now, the question is to find the angle theta that corresponds to point P, right? We know that x is equal to r cosine in polar curve, right? So x is equal to r, that's 6 cosine 2 theta. 6 cosine 2 theta times cosine theta, right? We're trying to find angle theta when x coordinate is equal to, right? So substitute 2 here, then that's going to be equal to 2 is equal to 6 cosine 2 theta times cosine theta. And we're going to have to use our calculator to find angle theta, all right? Well, I use 𝗔𝗕&𝗕𝗖 cos. So if we use that, we can find the angle theta using solve, right? So solve 2 is equal to 6 cosine 2 theta times cosine theta. And the theta is between, we're looking for the angle theta from 0 to the pi over 4 in this interval, right? Well, instead of theta, we can use x when we type this in our calculator, okay? So if we use our calculator, that gives us theta is equal to 0.580, right? So that's our angle theta. And here's one more question. Find the y coordinate of this point P, right? We know that y is equal to r sine theta, and r is equal to 6 cosine 2 theta times sine theta. That's our y, right? So when x is equal to theta is equal to 0.580, and when we have angle theta is equal to 0.580, here and here, our y coordinate is, well, we're going to have to put this in our calculator, right? That's going to be equal to 1.313, right? So when x is equal to, our y coordinate at this point is 1.313, okay? Question A60. Suppose a particle moves along the polar curve r is equal to 6 cosine 2 theta, so that at time t seconds, theta is equal to t squared. Find the time t in the interval from 0 to 1, for which the x coordinate of the particle's position is 1. Okay, this question is very similar to the previous question 859, right? Here, x is equal to r cosine theta, and r is 6 cosine 2 theta, and we have cosine theta. That's our x, right? But this time, theta is equal to t squared, and we're trying to find the value of t where x coordinate is equal to 1, right? So x in terms of t is equal to 6 cosine 2 times t squared times cosine t squared, right? And when x is equal to 1, the question is, what is value of t in this interval right here? we're going to have to put this in our calculator. So solve 1 is equal to 6 times the cosine 2t squared times cosine t squared, and we are trying to find the value of t from 0 to 1 inclusive. Oops, I missed comma t, right? Comma t. That gives us t is equal to 0.823. Okay, so that's our answer. Question A61. For the distance between two curves, r is equal to 6 cosine 2 theta and r is equal to 6, where theta is from 0 to pi over 4, what is the rate at which the distance between two curves is changing with respect to theta when theta is equal to pi over 6? R is equal to 6 when theta is equal to 0, so coordinate is here, and r is equal to 0 when theta is pi over 4, right? The coordinate is right here. So the polar curve is drawn from here to here, right? And the question is, what is the rate at which the distance between two curves? So at some value angle theta between 0 to pi over 4, let's say we have r here, right? The distance between two polar curves is here, right? That's our distance, right? At this angle value right here. So the equation of the distance can be written as d of theta is equal to 6, this is a 6, right? Minus this r right here, which is a 6 cosine 2 theta, right? So 6 minus 6 cosine 2 theta. And the question is, what is the rate with respect to theta when theta is equal to pi over 6? So we're going to have to differentiate this polar equation with respect to theta. All right? So dd over d theta is equal to derivative of 6. That's a 0. We have a minus a 6. Derivative of cosine, that's a negative sine 2 theta times derivative of 2 theta, 2, right? So if we simplify this, that's going to be positive 12 sine 2 theta. So far so good. And we're trying to find dd over the theta when theta is equal to pi over 6. So that is equal to 12 times sine 2 times the pi over 6, that's going to be pi over 3, right? So 12 times sine pi over 3, that's root 3 over 2. So that's going to be equal to 6 root 3. Okay, so the answer is a 6 root 3.